Hi, so welcome back to high school, I guess. We're going to discuss MET 154, pre-calculus college mathematics. And the reason this is called pre-calculus is because that way we can get all these credits to transfer. This is a 4 credit class through Eastern Arizona College. And it will transfer to any university anywhere. Doesn't matter the size, or any junior college anywhere. So it's a very transferable course. It may not always transfer as a 4 credit. Sometimes it transfers only as a 3, but it still is a transferable course. What we're going to talk about today is 6.1, which deals with square roots, basically, roots of numbers. So when we have a number, let's say we had something like 3, and we squared it, and we got 9, right? 3 times 3. Well, square roots is the reverse. We have the root. It's called square root. We have the square, I should say, which is 9. And we put it under what we call a radical symbol. And what we're trying to do is find the root that gave us this number. What was the root number or the base number that was squared to give us 9? Well, obviously, it's a 3. So the square root of 9 is 3. Now, this symbol right here is called the radicand, or the radical symbol, I should say. The number underneath it is called the radicand, or whatever else is underneath there. Could be an X or something like that. That's the radicand. And then this also has 2 other things. It has a power, but in this case, the power is 1, so we don't usually write it down. And it has something called an index. An index is the number in front of this. And it kind of squeezes right in here, and it's a 2. But over a period of time, we have stopped writing the 2. So we don't write the square down. See, the square root. But we don't put this 2 down anymore by convention, so we just understand it to be there. And we don't usually write the power unless we need to. We could have written this as 3 squared. Then you would probably want to multiply that out and then take the root, like that. If you notice, when you square a square root, when you square a square root, you get the number that was underneath, the 3. You get the radicand. This square and this index kind of undo each other. Okay, we can also have higher indexes. We can take cube roots, like the cube root of 27. Here we would have to write the index down. We know 27 is 3 times 3 times 3. So when we have 3 threes, 3, 1, 2, 3, the answer would be 3. Cube root of 27 is 3. The cube root of 64 is 4 times 4 times 4. We have 3 4s, so it comes out as the number 4. 64 is the cube root of 64. We can think of it this way, is the cube root of 4 cubed. The index and the power are the same. It comes out as a 4. So if the index and the power match up, then we just get the radicand. So that's a little bit about it. Let's take a look at square roots though first. So again, we don't usually write the index. The square root of 25 is 5. Now, technically, sometimes when we take a square root, there could be a positive or a negative value, plus or minus, because a negative 5 times a negative 5 is 25. And of course, a positive 5 times a positive 5 is 25. So for the most part, right now, we're concerning ourselves with just a positive answer. If we want a positive or a negative, we usually indicated that we're looking for a positive and a negative answer. But if we don't indicate it, it looks like we're looking for the principal square root, which is a positive answer. So let's try another one. What if they had a negative in front of here? Well, the square root of 25 is 5, and we simply put the negative with it. So that would be a negative 5. What if the negative sign was underneath the square root? In this case, we can't take it. You could try it on a calculator. Turn it on. And if you were using this calculator, you'd have to hit second x squared. And that gets you in the square root mode. And then you're going to hit a negative. You're going to hit this negative down here, not the minus sign, negative 25. But you see that it will give you a error because you can't take the square root of a negative 25 yet. We have to do some work to get to that one. So then you cannot have a negative in the radicand, okay? Now, could you do something like fraction? Certainly. The square root of the numerator is 9. The square root of the denominator is 8. 9 over 8. Don't put it back under a square root. What you're trying to do is get it out of the square root. We're trying to get it out of there. We're trying to find the root base of this square. Okay. Sometimes we have decimals. Probably want to do this on a calculator, but a little shortcut. It would have to have 4 decimals. It comes out as point. For these two, it'll be a 0. For these two, it'll be a 7. But you can also do it on your calculator. Second x squared. Let's clear that out. Second x squared. Let's clear that out. Second x squared. Here we go. Second x squared. 0.0049. And usually we want to close that off with a parentheses. Okay, 0.07. So square root of 0. What is the square root of 0? Second x squared, 0, 0. So the square root of 0 is simply 0. Square root of negative 25, remember, can't do it. It's got the negative under the square root. Not possible, does not exist. We can also do numbers that aren't perfect squares, like square root of 2. Here you'd have to use a calculator. You could take the square root of 4. Square root of 4 is the whole number 2. But if you're going to take the square root of 2, it's 1.414 approximately. If I was to take 1.414 times 1.414, you see I get very close to the number 2, 1.9999. You know, so pretty close to 2. It's not exact. So if it's not exact, put a little wavy lines. If it's exact, we put an equal sign there. So we can do different square roots. How about 487? Second x squared, 487. 22 point, and you know, it depends how many places you want to go out. We'll go out to the hundredths place, which is 2 places, the hundredths place, and then we're going to round it up because in the thousandths place, we have an 8, big number. So it's going to be 22.07. You know, and it just depends how far they want you to take it out. Okay. What if we had this strange one? We had 463 divided by 557. To do this one, what I would do is I would hit second x squared. I'd put 463 divided by, for the this line right here, 557, put it in the parentheses, and then hit equal. 0.09117. So if I want to go out to the thousands place, 3 decimal places, it would be 912. Write it up. So 912 thousandths, 912 thousandths. Okay. So this is your radical symbol. Sometimes we say radical 2 instead of square root of 2. Might call it radical 2. This is your radicand, the number 2, and so on. All right. No problems there. All right. I'm just following along in the book, and it says on example 14, it says for the given function, find the values. Function of x equals the square root of 3x minus 2. And it says find function 1. Okay, so all they're asking us to do is replace this x with a 1. Calculate that out. 3, that'll give me 3 minus 2 is 1. And the square root of 1 is 1. If possible, always take the square root. If not possible, if it's going to come out a strange number, sometimes we leave it. Okay. Okay, what if I had a 5? This is simply 3 times 5, 15, minus 2, 13. I might just leave this square root of 13 because that's kind of an exact answer. If not, I can go second x squared, 13, 3.60, and we'll round up 6. 3.606. It looks like the book wants us to carry it out 3 decimal places or thousandths place. And the last one, what if x was 0? All right, so we got 3 times 0, that's 0, minus 2 is a negative 2. And we would just leave it that way because we cannot take the square root of negative 2. So we just leave it that way or say it's the null set, doesn't exist. Okay. The domain, well, let's look at the domain. Let's take the square root of x. The domain means all the numbers you can put in there. So we found out that we can put in a number like 0 and we can get 0. We can put in a number like 1, we can get 1. We can put in a 4 and get 2. But can we put in a negative 1? Put in a negative 1 and domain error. So the smallest number we can go down to is a 0. So if we were to plot this, here's your x values. We're putting in x values. This is your y answer right here. This is your x. The square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Something like that. So the domain is any number that's greater than, on this particular one, it can't be a negative number, so it's got to start at 0. Now, the one in the book they gave you was the square root of x plus 2. Well, the smallest number we can substitute in for values of x must be 0 or greater. And we could also put in decimal numbers, but x has to be the smallest number we can use is 0. So if we put in a 0, we've got the square root of 2. If we put in a 1, we've got the square root of 3. If we put in a 2, we get the square root of 4, which is 2. This is going to be 1.4, just one decimal place. This is going to be 1.7 if you look them up on the calculator. So on this particular problem, when x is 0, y is over here at 1.4. When x is 1, y is up here at 1.7. And finally, when we get out here to 4, y is up here at 2. So our graph is going to look something like this. But could we put in a negative number? Well, let's see. We said x can't be a negative number. Well, but we're adding 2 to it. If it was just x, it couldn't be. Well, let's see what happens if we put a negative 2 plus 1. That gives us the square root of 1, which is 1. So at negative 1, we could have a 1. And at 0, negative 2, excuse me, this would give us 0, which could be a 0. So we could go into the negatives, but only so that it can y can only be 0. And you can see it kind of shoots out, and then it kind of levels out a little bit. So we can kind of see there's a little bit of graph. Maybe my drawing's not the best, but you can see it's kind of like the same graph we had before, but it's moved over a little bit. So it is possible to put a negative number in here as long as you have some other numbers to go along with it. But you can't go any numbers. If I put a negative 3 in here, then I'm going to get a negative 1, and I can't find the value of negative 1. There is no square root. So I can only put numbers as long as the sum of those numbers is 0 or bigger. 0 or bigger. All right. We mentioned about a squared, so let's take a look at some problems here. Well, here they try to trick us a little bit. They're putting a negative number in here. What is the square root of negative 16 squared? Well, we said when we square a square root, we get this thing. Well, not exactly. We get the absolute value of this answer. So if we square a square root, these cancel out. We get a negative 16, but we have to take the absolute value of that answer. So the answer is really only 16. If we have something like 3b squared, then the answer is really just the absolute value of 3b. Well, the absolute value of 3 is 3, but b might be a negative or a positive number. We don't know. So it's just going to be 3 absolute value of b. We usually, by conformity, just usually say it's 3b, and we assume that b is positive, but it could not be. We also mentioned earlier that we can have cube roots. Let's say we want to do a cube root on this calculator. On this calculator, if you want to find a cube root, you're going to hit, first of all, you're going to have to put in the cube root first. So let's clear this out. We're going to have to put in the 3 first. Then we're going to hit second and not up arrow, and not x squared, excuse me, but up arrow. Second, up arrow. See, this 3 is filling in this little x right there. And then we're going to put in our 8, and then we're going to hit equal 2. So the cube root of 8 is 2. And again, the cube root of 2 cubed, 8 is 2 times 2 times 2, 2 cubed, is whole number 2. Whole number, not radical 2, but whole number 2. Okay, let's try a hard one here. Cube root of a negative 216 over 125. Now, on cube roots, this is an odd index. It's an odd number, right? So on any odd index, you can have a negative underneath. On any even index, 2, 4, 6, you cannot have a negative underneath. Unless, you had a power, but if you just had 16, you couldn't do it. But on this problem, you can. So what is the cube root of 216? Well, what we can do is we can hit second, uh, x cubed. So we hit this. Whoops here. Oh, we first want to put in our index, excuse me. So we want to put in the 3, second, up arrow, 216, 6. 6 times 6 times 6. And this will come out negative. It's okay. You can do that on an odd index, but not on an even. And the cube root of 125 is 5. So it's a little tricky there. Negative 6/5. Here's one, the cube root of x cubed. 3's, cancel out 3's, we just get x. And the cube root of 0. Cube root of 0 is the same as the square root of 0, which is the 5th root of 0, which is 0. So that's pretty easy. Let's try a few more. Cube root of negative 27. Once again, you can have a negative. That's going to come out negative 3. I'm not going to worry about decimals. You can look those up. Cube root of negative 8. 2 times 2 times 2 is negative 2. Cube root of negative 8y cubed. Okay. Cube root of negative 8, negative 2. Cube root of y cubed. Indexes are the same. Y. Let me show you a little trick. What if this was y to the 6? This would be negative 2. 3 goes into 6 2 times. We can divide the power by the index. Power divided by index, pi. Power divided by index. Index into power, 2. So that's kind of a quick way of doing it. We're not going to worry about cubing them. We mentioned about higher roots. Let's take a look at a couple of those things. 5th root of 32. That would be 2 times 2 times 2. This would be 2 to the 5th root, 2. And again, if you're having a little trouble, you can always use your 5th, second, up arrow, 20, what was this, 32, equals. So second, first put in your index, second, up arrow. Okay. So I think we're going to cut it quits right here. You can mess around with some of these other ones. You want to take a look at what your practice is, basically doing most of these problems. Going through here on page, most of these are just simple answers. Make sure you go through them, try them, get used to using square roots and cube roots. Okay, let's sign off.